Hello everyone. Today we're working on Notes 8.5 Properties of Logs. So when we have exponents and we have something like x to the third times x to the seventh, we get x to the 10th, right? So when we're multiplying, we add the exponents. That is the same idea here with the product property. When we multiply two values together, we can split that log up using addition. So again, when we have multiplication, we use addition, just like we do with our rules of exponents. Then what? What if we had something like x to the seventh divided by x to the third? What do? We subtract the exponents in that case. Same idea with the quotient property. With the quotient property, when we have division, we can split that log up into two separate logs using subtraction, just like we do with exponents. And then the third property is the power property. Use some purple. The power property. The power property says if we have an exponent involved, we multiply by the exponent. Kind of like when we have a power to a power, what do we end up doing? We end up multiplying those. So when we have that exponent up there, we basically take that exponent to the n power, we drop it out front and make it n times the log. So how and why are we going to use this? The first way we're going to use this is we're going to just practice expanding one log into multiple logs. We're going to practice condensing, taking multiple logs and smushing them back together to get one log. And then we will use those properties to help us solve some logarithmic equations. Okay, so again, when we have a multiplication, we're going to split those logs up with addition. When we have division, we're going to split those logs up with subtraction. And when we have an exponent, we're going to drop that exponent out front using multiplication. So let's take a look at our first example here where we're going to expand. So the first thing we want to see is we've got this division. So we're going to start by separating our log using subtraction. So the base stays the same. They're both log base 2 in this case. So we're taking this division and we're splitting it up using subtraction. Then what do we notice? Well, if we look at the 4x squared, we've got some multiplication there. So we're going to split up the multiplication using addition. So this minus log base 2 of y just keeps coming along. So we split up the 4x squared using addition. And there's my 4, and there's my, x squared. Don't forget the 2. Then what? Then the last thing we should notice is we have this x squared here. We said that when we have an exponent, we drop it out front. So we're going to take this 2 and drop it out front. So we'll have log base 2 of 4 plus 2, there's that exponent, log base 2 of x minus log base 2 of y. Now, in this particular one, because of the way the numbers worked, log base 2 of 4, what is that? 2 to what power is 4? That's actually just 2. So we could go ahead and simplify that at the same time. And now we have the expanded form of our logs. We have the log of x by itself, and we have the log of y by itself. All right, let's try another one. Log base b of 3b squared square root of x. First thing we want to do is rewrite that square root of x as an exponent. So that is 3b squared x to the 1/2 power. Okay, then what? Then I've got multiplication. I've got the 3 times the b squared, I need another highlighter up here, times the x squared. So what are we going to do? We're going to separate those using addition. Remember, we separate multiplication using addition. So that'll give us log base b of 3 plus log base b of b squared plus log base b of x to the 1/2 power. So again, separating the multiplication using addition. Then what? Nothing I can do with the first piece. The second piece, I have an exponent up here, so that needs to get moved to the front. And the same with the 1/2 gets moved to the front. So we'll get log base b of 3 plus 2 log base b of b plus 1/2 log base b of x. Now if we look at this middle one here, log base b of b, what is log base b of b? That says b to what power is b? This is just 1. So then that gives us log base b of 3 plus 2 times 1 plus 1/2 log base b of x. 2 times 1 is just 2. Put that out front. You don't have to. It just looks a little neater in my mind. And then the rest is the same. So now we have those logs separated into individual logs. Last but not least, number 3. Slide this over a little bit. We've got log base 3 of x squared over 9y cubed. First thing we're going to notice is, and so good. First thing we're going to notice is that division. So I'm going to use that division. I'm going to split it up using subtraction. So log base 3 of the top minus log base 3 of the bottom. All right. What do we notice here? We've got this exponent. What do we do with the exponent? We drop it out front. The line here. So that gives us 2 log base 3 of x minus, what do we have here? We have a multiplication. So we'll have log base 3 of 9 plus, with multiplication, we split that up with addition. But this was minus this log. So I need parentheses here because it's minus everything after that. Now what? Now we've got this 3 that needs to be dropped out front. So we've got 2 log base 3 of x minus parentheses, log base 3 of 9. 3 to what power is 9? That's just 2 plus, drop the 3 out front, 3 log base 3 of y. Distribute that negative through. I'm going to start off with the negative 2 here. Just put it out front. I don't really know why. 2 log base 3 of x minus, don't forget you have to distribute that negative, minus 3 log base 3 of y. And now we've got those separated into log of x and log of y. And again, the base stays the same the whole way through. Now, let's look at going the opposite direction. So instead of expanding them into the separate individual logs, what if we want to take the separate individual logs and smush, technical term there, smoosh them back together? All right, so what are we going to do? First of all, we've got log base, no base there, it's really the common log base 10, that's not till tomorrow's stuff, and we've got 4 log of y. First thing we're going to do is take any numbers out front and push them back up to the exponents they came from. That'll give us 3 plus log of x plus, nope, we're moving the 4 up, plus log of y to the 4th. Okay, then what? We've got addition. Where does addition come from? Addition comes from multiplication, so we'll have log times, log of x times y to the 4th. All right, we're just going to leave the 3 alone since we don't really know anything about the common log. So that's what we've got. Let's look at number 5. First thing we want to do again is look for any coefficients, so we can move those back up. So the 2's going back up. That leaves us with log base 2 of x minus log base 2 of y minus log base 2 of z to the second power. Then we're just going to work from left to right. So I've got subtraction here. So that comes from division. So I'll have log base 2 of x over y. Again, when you're smushing it back together, when you're condensing it, you lose a log. So these two individual logs get put back together with just one log, and then the x and the y are divided because we had subtraction. Minus log base 2 of z squared. Again, we have subtraction, so we're going to divide. Now, I don't want to make it crazy complicated with division and having to create a complex fraction. The z squared, since we're dividing, will end up in the denominator. So I'll have x over y z to the second power. Again, subtraction gets us division. So I'm going to divide the x over y by z squared, which is the same as multiplying it by 1 over z squared, which keeps that z squared in the denominator. Again, when we're smushing it back together, when we're condensing, we lose the log as we put it back together. So we're trying to, in the end up with only one log. Okay. And last but not least, we've got 1 plus 1/2 log base 3 of x minus log base 3 of y. First of all, push the exponent up. 1 plus log base 3 of x to the 1/2 minus log base 3 of y. We're going to leave the constant alone for right now. Nah, let's deal with that. 1. Log base 3 of what is 1? Log base 3 of 3 is 1. So it looks like this. All right, well, what does that mean for us? Well, we've got addition, so that means multiply. So log base 3 of 3 times x to the 1/2 minus log base 3 of y. Then what? Then we've got subtraction. What do we do with subtraction? We divide. So that'll be 3x to the 1/2 over y. And now we have smushed those back together to get one log. Okay, so you say, well, why is that important? Well, because we want to solve some equations. Yesterday we solved equations where we had log equals log. What we were taking the log of was equal to each other. But now I've got two logs. So I need to smush this back together to get one log. It's subtraction. So subtraction comes from division. So I will have log base 4 of 48 divided by x equals log base 4 of 6. Now, my logs match, therefore what I'm taking the log of has to match. Now this becomes like we did yesterday, where we solved this. I'm going to multiply both sides by x. That gives me 48 equals 6x. Divide by 6, so x equals 8. In these problems, you have to check for those extraneous solutions, because remember, you can only take the log of a positive number. So when I plug the 8 back in, I get an 8 here. Is it possible? Is it legal to take the log of 8? It is, so that's going to work. How about the next one? So here we have addition. So addition comes from multiplication. So we're going to multiply those together. Now here's a case where I don't have logs on both sides. So I'm going to rewrite it as an exponential. I'm going to pop it. I'm going to take the 6 over. It pops the 2 up. And I'm left with x squared minus 9x, just distributing that. When I rewrite it as an exponential, the log goes away. Now what? Well, now I've got x squared minus 9x equals 36. Subtract the 36 from both sides equals 0. Then what? Then I'm going to factor. That's going to give me minus 12 and plus 3. Set each factor equal to 0. I get x equals 12 and x equals negative 3. Can I plug in the 12? I get a positive. I get a positive, so yes. Can I plug in the negative 3? No, because I'd be taking the log of a negative. You're out, so just the 12 for an answer.